Welcome to the second day of Sweden Innovation Days and our session on Fossil-Free Aviation 2045. Why 2045 to start with? Well, by 2045, Sweden is to have zero net emissions of greenhouse gases into the atmosphere. And this includes, of course, all sectors. Already 2030, all Swedish domestic flights have to be fossil-free. My name is Verena Adamheit, and I work at the Swedish Energy Agency. We've been leading the way in aviation's transition towards the climate goals since 2018, providing more than 150 million Swedish crowns for national research and development projects. And we continue to support R&D and commercialization of innovations even in the future. In the next 45 minutes, we want to show that several different paths are needed to reach fossil-free aviation and what the solutions might look like. Like in all other sectors, we need to get away from fossil fuels, also when it comes to aviation, not only in Sweden, across the whole world. But how? Simply stop flying is not a solution, as aviation plays a vital role in the global transportation infrastructure, connecting people and goods across the whole world. So we must find ways to make aviation clean. In this session, we will provide an overview of the different challenges and possible solutions to achieve fossil-free aviation. Sustainable aviation fuels, SAFs, hydrogen, and electric-powered aircraft are some examples of solutions. We will listen to some inspiring examples from aircraft providers, an airline company, airports, and a potential fuel producer. We also have a representative from a city located in northern Sweden, where aviation is crucial for the economic development of the region. Having said that, I would now like to introduce our eminent speakers. Jimmy Bergqvist is Senior Vice President Business Development at Braathens Regional Airlines. John Nilsson is Strategy Manager for Electric and Hydrogen Aviation at Swedavia, which owns and operates 10 airports in Sweden. Morten Bräck is Project Leader Fossil-Free Aviation in northern Sweden at Umeå Municipality. And then we have three distinguished guests online, and I'm happy to welcome Julia Alrud, who is Head of Strategy at Växjö Energy and Project Leader for a ReSAF project. Oskar Thulin is Technology Project Manager for Next Generation Power and Propulsion at GKN Aerospace. And last but not least, Kristoffer Lewandowski is the Head of Research and Development Program at HARD Aerospace. Warm welcome to you all.
Thank you.
So let's get started. Jimmy, you are our first speaker. Your company is heading towards net zero already in 2030. Please tell us more. The floor is yours.
Many thanks, Verena. And first I would like to say that really appreciate to be here today, of course. And in total, I have only 5 minutes. It's a very short time to, talk about an airline strategy. But I will start first off with just for you who doesn't know about our company, just 30 seconds on who we are. We are an airline mainly operating in domestic Sweden. And we are focusing our business out of Bromma Airport, a city center airport. And in total, we operate roughly 20 routes. We've been working very long with the sustainability agenda, and we have been IOSA certified since 2009. Actually the first airline ever. And just recently, we are now certified according to SBTi. Just some bragging on what we have done so far, and let's focus on the last points there. In 2022, we were actually the first airline to carry out a commercial flight with 100% SAF. And that flight took place between Malmö and Bromma. And this was a joint project with ATR, which is the aircraft manufacturer, Neste, and also SAF supplier. The ATR aircraft flew with 100% SAF on both engines, and actually that was the first time ever done. Also, during 2022, we started the first commercial route, which is operated with 50% SAF all year around. And that is in cooperation with Volvo Trucks, meaning that, Volvo today can fly between their two main head offices in Lyon and Gothenburg, more or less the best way possible. Going into the actual agenda for today, the net zero, and our road towards net zero in 2030, we are focusing on 4 pillars for achieving that. And the first one is, of course, have the right aircraft for that. We currently today operate the ATR 72-600, which is by far the best aircraft in terms of fuel economy. It's actually around 40 to 45% better than a comparable jet in the same size. So that's a key enabler. But the most important one is the second pillar, I would say. It's about SAF. For us, the agenda is that from 2030, we will operate with 100% SAF operating our domestic routes. The third pillar would be, new technology like electric and hydrogen aircraft. And today, we also have an LOI in place with one of today's speakers, Heart Aerospace. And most likely, and hopefully, we will be the first airline operating domestic route with electric aircraft in Sweden. And finally, the fourth pillar will be CO2 capture. As you all know, by introducing SAF instead of fossil fuel, you can reduce the CO2 emission by up to 80%. But we need to take care of the remaining 20. And for that, we are looking into different carbon removal projects currently ongoing. But this should be paid for as well. And for that reason, we have during many years developed many different kind of products to be able to, our customer to easier make the right choice. For example, in 2022, we launched our new website where we have the 2 different types of tickets you can buy. You have the ordinary, and then you have the SAF tickets. I would say we were the absolute first one in the market with this. So it makes it very, very easy to buy a ticket with 50% SAF. And also for the corporates, we have several products. And one of them is the ordinary corporate agreement, where you have a discount, normal discount. But the difference here is that all the tickets sold under these agreements are as SAF tickets. And we recently signed a new agreement with one of the major banks in Sweden. And they will only operate, domestic Sweden with this SAF ticket. We also have other projects products for smaller corporates, like a punch card, where you can buy tickets, and they all include SAF. And you can, as an additional, also decide to buy as much SAF as you want if you wanted to reduce up to 100% in total. So finally, my short 5 minutes is soon ending. So what I would like to say finally is that, all the products, we are here today talking about, future fossil-free aviation. But actually, I'm saying that this is achievable today. and so the future is already here. What we as an industry need to do and work together towards is especially, make sure that we have the availability of the SAF fuel for the years to come. I think I made my 5 minutes. Was that okay?
Thank you very much. The future is already here, quite like that.
Yeah.
Thanks for this overview. We continue from an airline to an airport. John, from your point of view, how can airports enable fossil-free aviation?
Well, first of all, thanks for having me here today. I'm going to do, as Jimmy, a short introduction to Swedavia, and then I'm going to go more into how we are working towards fossil-free airports or aviation industry. So first of all, at Swedavia, we own and operate 10 airports, from Kiruna in the north to Malmö in the south, via Stockholm Arlanda and Stockholm Bromma airports. And there are different characters. Stockholm Arlanda Airport is an international airport, 25 million passengers yearly. And for example, Ronneby Airport in the south of Sweden is a very small airport that has more a regional character. At Swedavia, customers are essential to us, and that's what we focus the most on, but we also have a sustainable view on the whole customer approach, from economical sustainability, from environmental sustainability, and from social sustainability. And environmental sustainability is one of the core aspects to drive the fossil-free aviation of the future. At Swedavia, we've been working with fossil-free aviation for a long time. Since 2006, we already put very aggressive goals to be net zero from our own operations. We reached that in 2021 for all our 10 airports. And now we hope to have fossil-free airport operations, including all operators, already by 2025. And we are in close cooperation with our airlines and our ground handling operators on our airports to make that achievable. And also, together with the aviation industry in Sweden, we are pushing forward towards a fossil-free travel 2030 and fossil-free domestic flights from our airports in 2030 from all Swedish airports. So more into detail, what are we doing to reach those fossil-free goals? Well, we are supporting all operators at the airports to evolve fossil-free operation, from the air side to the land side via the terminal facilities. We are reducing emissions from and to the airport, the door-to-door travel from the ground transportation, by prioritizing sustainable travel, for example, trains or sustainable buses or sustainable car sharing or cars. But we're also enabling fossil-free domestic air travel. And to enable fossil-free domestic air travel and international travel, we have 3 different goals that we have. We are looking into sustainable aviation fuels, we are looking into electric energy, and we're looking into hydrogen energy. And all those 3 types of energies will play a big role in the future on airports. And we have to adapt our airports in order to make sure that we are not acting as a brake towards the fossil-free aviation industry. When it comes to trying to adapt our airports, we have 5 key aspects that we are looking into that are very important for airlines. It's the turnaround time, for example. How can we cope with the new types of energies that might demand a different handling for the turnaround time? It's the charging and the fueling needs. How should we charge the electric airplanes of the future? What are the needs? What are the demands from, for example, Heart Aerospace or Bra Aviation in the future? Of course, there's the airport flexibility. We are working towards having an airport that can cater for all types of airlines, and especially trying to make sure that one stand can fit all. And we are in close cooperation with both the research institutes of Sweden and with our customers and with our ground handling to make sure that that flexibility is achievable in the future. Of course, that transpires into safety and security aspects. We need to make sure that the high standards of safety and security in the future are still, of today are also met in the future when it comes to recharging next to maybe refueling hydrogen or refueling jet fuel. And last but not least, we are looking highly into traffic forecasting and peak demand for the future. What part of the routes in the future will be electrified, will be used with fuel cells and hydrogen, and that affects immensely how we will plan our airport in the future. And we need to be ready already today in order to make sure that we can be ready with infrastructure in the future. So we need to understand today that share of the aviation industry. So we have looked into these parts, and we have made, in a cooperation with the Umeå municipality and a project that Morten will probably talk about a bit more, we have also shown how it could look in the future on Umeå airport, for example, where we have designed, and this is a vision for the future, I must add, a stand of the future with electric aviation, where you can see how it might look in the future. On that fine picture, thank you.
Thank you so very much, and thank you for emphasizing the need for innovation on Sweden Innovation Days. Let's now turn north. Morten, the economic region of Umeå cannot survive without aviation. What about Umeå's climate goals then?
That's correct. Thank you for having me here. My name is Morten Beck. I work for the city of Umeå and as project leader for the fossil-free aviation in northern Sweden. And here we see a map of Sweden, and Umeå in the circle. We are situated around 650 kilometers north of Stockholm. So for Umeå, of course, the aviation is crucial for Umeå and the region that we are living in. Umeå is a city of around 135,000 inhabitants. We're steadily growing towards 200,000 inhabitants in 2050. We have very high climate goals. We're part of the Viable Cities and the EU climate city contracts, for example. And of course, we want to be in the forefront in the fossil-free aviation. And that's why we run this project, fossil-free aviation in northern Sweden, together with our partners, Swedavia here, Biofuel Region, Research Institute Sweden, and RISE Processum. And the project was financed by Swedish Energy Agency. And Umeå, I must say that Umeå as a city wants to be climate neutral in 2030 already. Some of the project results. Here's a map of Umeå, you see in the west, and Finland to the east. And it's the arrow between those cities. Electric aviation was part of the project, and we see that for the region, electric aviation seems to be a very good fit. And for example, to fly between Umeå and Vasa in the future. And of course, we want to fly with Hot Aerospace ES-30 in the future. Between Umeå and Luleå or Umeå, Vasa, for example. And also, we'll look at the cross-border, for example, Sweden-Norway, Sweden-Finland. And in this project, we've increased more knowledge about infrastructure and charging at Umeå Airport, as John told us. Umeå is part of the green transition in the northern Sweden, and hydrogen is a quite hot topic, and hydrogen aircraft was also something that we looked upon. And we made a future scenario for the year 2040 for hydrogen aircraft at Umeå Airport, and we see that it will demand quite some liquid hydrogen each day, between 3,000 and 7,500 kilograms per day, for example. Also aspect as supply, how do we get it in the region, safety aspects and the infrastructure that will affect not only the airport but the whole society, I would say. And also SAF, sustainable aviation fuel, that we'll be hearing more about later also. So how could we produce SAF from forest residues in northern Sweden? What business opportunities exist? And for example, how does the EU legislation affect SAF production? We believe that the sugar platform and as well as the gasification and Fischer-Tropsch will be two hot candidates in the future. And with that said, Umeå and northern Sweden will be ready to go for the fossil-free aviation in the future. So thank you very much.
Thank you very much. That was a quite tour through northern Sweden. Let's now turn to our digital participants and also to the technical solutions that we want to present. And Julia, you are first out. Morten already mentioned forest residues seems to be a perfect handover to you. The floor is yours.
Oh, thank you. Yeah, and now it's time to focus on the southern part of Sweden instead, since we have a project ongoing in the southern part of Sweden. Oh, sorry, I was too quick there. So we have a project subsidies by the Swedish Energy Agency called From Forest Residues to Sustainable Aviation Fuel. We call it RESAF. And as you see, we are 6 partners working together in this project. And we are all needed. We are together the value chain. Södra is responsible for the forests, they are forest owners, and they have a lot of forest residues that can be used for good matters. And Växjö Energi, that is what I represent. We have the site, the possible location for a production site. And then we have KLM, the aviation company, that are waiting for sustainable aviation fuel. In the middle, we have Sky Energy, that is a very committed developer who support the process to make it real. And on the top, we have RISE, who is looking into sustainability aspects and also is part of the technical development of the project. And in the bottom, we have 2030 Secretariat that is responsible for external communication. And what we have today is a combined heat and power plant production in Växjö, in the southern part of Sweden. And it's running 100% on renewables. It's from forest residues. So today we are producing district heating, district cooling, and electricity. And for us, it's very interesting to see, is it also possible to produce fuel at this site? So we look into an integrated solution. And this is a picture of the process. So we have looked into this going from biomass to feedstock treatment to gasification, syngas purification, syngas conditioning, and Fischer-Tropsch synthesis. And after that, we come to SAF together with some byproducts. And the pre-feed that have been achieved show that this is feasible. It's doable technically. Unfortunately, it's quite costful to the investment cost. So we need to find a good solution for that, of course. And we have some lessons learned. So first, to see on sustainability aspects, we can say that a positive view of bioenergy is a prerequisite. So if the European Commission say that the bioenergy is not sustainable, it's really hard to make SAF from forest residues. But we think the opposite, of course. The calculation from right side says that the GHG emissions will be reduced by 96% with our concept compared to a fossil reference. So that's a really, really good result. To make the process sustainable, an efficient use of resources is key. So it's very important to make a process with efficient use of all carbon, especially. Oh, sorry. Then to talk about how to do it, we feel that to have this customer in the inner circle of cooperation, as we have KLM, that is a success factor. That is really good. We have also seen that it's a great demand for engineering resources and other key competencies. And as a way to find a solution for that, we think that next step would be to have an even closer cooperation with technology suppliers. In the same way as we today have a customer really close, we want to add a technology supplier very close to the development. And in the end, as I have already said, the investment costs are high, but it is possible with financial incentives on national level and on international level. It's quite expensive to be a front runners, but we need front runners. Okay, thank you.
Thank you very much, Julia, for this introduction and a tour about SAFs and re-SAFs. We turn to you, Oscar. According to your homepage, GKN is shaping the future of flight, and I understand that you want to stress on hydrogen. So the floor is yours.
Thank you very much. My name is Oscar Tulin. I come from GKN Aerospace, and I will present on hydrogen to enable fossil-free aviation. Right? Let's start. Okay, so just to give a brief overview what GKN is, GKN Aerospace, and the engine division. We are about 4,000 employees in the engine divisions, and 2,000 of those are employed in Sweden. We are involved in various markets for aerospace engines. In the civil market, we are a partner in 70% of all active aircraft engines. In the defense, we have the military fight engine for the Gripen fighter, and also partner in other programs such as the Joint Strike Fighter. We as well work on the space side for the Ariane program for fuel pump turbines and exhaust cones. So with this background in both aviation and heat exchanging turbo machinery using hydrogen from space, we have a strong position to enable a hydrogen-powered flight for aviation. All right, so I'll start off with a picture of the current market. So the plot in the bottom middle part is a look on how the current market looks like in terms of fuel consumption, total fuel consumption per year, and the typical flight missions that they are served by, so it's wide body and single aisle and so on. The fuel consumption here can be seen to be directly related to the emissions then from aviation as well. So you see the dominating parts is the single aisle part and as well the wide body. We have color-coded a few different missions routes here with different distances that matches with these different parts of the segment. And if we then apply what could be available in 2050 towards this, we see some different platforms and how they can play a part. Everything here is dependent on how much energy really you can squeeze into a certain amount of weight and volume. So starting from the short distances, they can be battery electric. Then we have the hydrogen fuel cell. That's mainly towards the regional market, with some going into the single aisle market. Then there is the direct burn hydrogen combustion, which is covering both single aisle as well as the wide body. And along the distances, you also have the sustainable aviation fuels. They're weight efficient, but there will likely be a limited supply, so hydrogen is very much needed. As you see, hydrogen is a key enabler for fossil-free aviation based on the market and the emissions we have today. All right, that's why we are looking at the direct burn hydrogen aircraft engine. So to really describe the challenges here, it can use a fairly conventional engine, except from you need to adapt it to cryogenic hydrogen that is very, very cold. That needs requirement of the tanks, of the fuel system, and the combustor. The H2Jet project, financed by the Swedish Energy Agency, with a lot of partners here, in that one, we have focused on the critical subsystem for gas turbine-based hydrogen propulsion for medium-range civil aircraft. And we find this project that we can reduce the climate impact with more than 50%. As you know, the hydrogen, it's combusting hydrogen and oxygen. So you only get water as the byproduct. So it's fossil free. This is a good part. From this part that we still have as climate impact, then we have the contrails from the water vapor. However, this assessment is made without specific contrail avoidance devices or measures, which there are ideas in order to alleviate. So there is significant improvements that can be made here. So we find it very promising to reduce it further. In this project, we have also worked on different hardwares and tests. We have conducted heat exchanger tests within Chalmers. Here you can see on the left-hand side. We also manufactured different types of pipes for the future fuel pipes. And we have developed pump demonstrator hardwares and tested those ones in a pressure test as well. And to be said, the heat exchanger part here recuperates the exhaust heats from the engine. So it reuses that in order to preheat the fuel, so you get a more efficient engine. All right. We also are invested in the fuel cell hydrogen flight. In United Kingdom, we lead a project towards development of these propulsion systems. And on the Swedish side, there is also development on a fan matched to this in the Elephant project, which is also financed by the Swedish Energy Agency, and where we're working together with KTH. In this project, we have been looking at the design of a propulsor, also acoustic analysis for low future noise levels, as well as manufactured blades in aluminum and carbon fiber, and tested those one in mechanical vibration tests. And then to end, with a need for future development, key is here to adapt to the cryogenic environment with hydrogen. It means tanks, fuel system for both platforms. We also have on the hydrogen turbofan side specifically, development of low NOx combustion chambers, lightweight integrated hydrogen preheaters, as well as better understanding of the contrails from burning hydrogen. Here to the right upper part, you have the Airbus aircraft concept for a future hydrogen 150 passenger aircraft. Then there is also the fuel cell. There the need is for to increase the efficiency for the fuel cells and specific power of those ones, so they're weight efficient, as well as the thermal management and getting rid of the waste heat from those. To the bottom right-hand side, you can see the GKN fuel cell regional aircraft concept, pushing the limits for the range and the passengers both with the 48 passenger concept here. EU and the aerospace industry now invest in hydrogen propulsion in research and development within clean aviation. So it's a good thing going on there. We also see that the Swedish national programs are key for future Swedish participation. And with these programs and a good effort with everyone pulling together, I think we can make this. Thank you very much.
Thank you very much for this positive message. So we've spoken about SAFs and resafs and hydrogen, and of course, the missing piece is the electric aviation. So Christopher, your company believes in electric aviation and that it will change the way we are traveling. Please tell us more.
I will. Thank you. So I can't see the slides, but
We can see it.
okay, there we go. First, a few words about Heart Aerospace. We're a Swedish company that designs and builds electric aircraft. We're about 160 employees, and we're actually a spin-off from a Swedish research project that was funded by Vinnova, the Swedish Innovation Agency. And since we started in 2018, we've received venture capital funding from some of the world's leading climate funds. Electric aviation happens in many places at the same time. We have the urban air mobility programs, the sort of flying taxis, which is not really solving a climate issue more than it's solving a traffic issue. And on the other side of the spectrum, we have global air travel, traveling across the Atlantic. And there we haven't really seen any promises on new technologies like hydrogen before 2035. So the question is, what can we do now? And that's why we position ourselves in the middle with regional air travel, which there is a large demand for, and there's a low technical risk and attractive unit economics in this. So regional air travel stands for about a third of the aviation emissions in the world today. So travels under 1,500 kilometers stands for a third. Traveling under 500 kilometers stands for about 6% of the emissions today. And that's where we are focusing on. A good example is Norway. They have a very large regional network flying short routes. I think their shortest route is 7 kilometers, but it makes sense to fly that route because driving around would take 5 hours. But it doesn't look very different in Sweden. So these are the possible routes within Sweden that are under 400 kilometers. Of course, not all of them are traffic. Right now, it looks a little bit more like this. So you can see the yellow spaghetti are current routes, whereas the blue spaghetti is possible routes. And of course, it looks a little bit similar in the US. So what we're developing is not a niche product for the Nordic market or the Norwegian market, but it could actually go global. But there are problems with regional aviation. The current technology, jet engines, using that for regional aviation is remarkably inefficient. You have about twice or half of the fuel efficiency as you would for longer routes, is very costly. And you have to perform a lot of maintenance on your aircraft because the engines don't age by the route length, but rather on how many turnarounds you do. It's also very noisy, which is a big thing for city airports, for example. And you have both local and global pollution. We believe that electric aviation can solve all these issues: climate, the profitability for the airlines, and also by doing that, increase the connectivity all across the world. And this is our solution for that. The ES30, which is developed to work with airlines' existing business models. It's a 30-passenger hybrid electric aircraft that can travel 200 kilometers all electric and 800 kilometers in hybrid configuration. And it will enter into service in 2028, and you will be able to charge it in 30 minutes. And as I said, this is not a niche product for the Norwegian market or for smaller markets. Our biggest market or our customers are actually in North America. So we have orders from United Airlines and Mesa Airlines, 100 airplanes each. And we also have an order from Air Canada for 30 aircrafts. And as Jimmy pointed out in the beginning, we also have a letter of intents from Bratens Regional Airlines, for example, working in the Nordic as a regional operator. And we're very proud of our investors, our customers, and the technology development that we've done so far. But this is our biggest asset. This is our team. And we have experience from 100 different aircraft programs across the world. And we've certified airplanes on 5 different continents. We are currently 27 different nationalities. And it's not just because it's fun to be a lot of people, but this is what's required to actually develop an aircraft and take it all the way through certification. Thank you very much for having me.
Thank you very much. I think we got a real good impression of what is happening within the industry through all your speeches, and I think we all agree we could discuss this for a whole day now, but we don't have quite that much time, so just one question to you all, and I need to ask for 30-second statement. From your perspective, what are the key enablers on the way to fossil-free aviation? What needs to happen? Maybe to start with you again, Jimmy.
Yeah. And for us, it's very, very simple. It's all about SAF, sustainable aviation fuel. We need, as an industry, cope together, make sure that we have the availability. I mean, in the short run, that's the only solution. Okay. There are many solutions in the long run, but in the short run, it's the SAF.
Okay, yep. That's your perspective. John?
Well, for us as a first enablers is to target incentives and financial aid to make sure that we can get over that first investment and then enable a bigger share of the market for electric and hydrogen aircraft.
Okay, thank you. Morten?
I would say like a strong political will and incentives to these first movers, if it's production plans or
okay.
So more incentives, I would say.
So a lot about first movers here. Our digital panel, Julia.
Yeah, I would like to talk about the big picture, because I think fossil energy is like a drug. Everyone knows that you need to stop immediately, but the short-term positive effects are so strong that the world cannot resist. So our biggest challenge is to really leave the fossil society and to give the renewable alternatives a fair chance to create a sustainable future. So fossil energy must not be an option. Then SAF and all other good can be reality.
I think we can all sign that message. Oscar?
Yeah, so for us, it's of course a combination for the longer ranges, or the medium to longer ranges of SAF and hydrogen with a mix. And key there to make that happen, of course, and if we talk about the technology side from an Energian perspective, is a strategic investment into it with multiple strategic research projects.
Okay, investments here. And Christopher?
Yeah, I mean, I agree with all the previous speakers, and I think it's essential that we make sure that there is funding and capital means to make sure that good ideas don't remain good ideas, but that they actually reach the market. And on top of that, we need to be extremely bold in the policies that we bring forward if we want to accelerate this.
Thank you. Just a short shout out. Will we make it together?
Sure.
Together.
Definitely.
Sure.
Great.
Together,
That's a good
yes.
message. So with these answers, we have come to the end of our session. Thank you very much again to all our speakers. We hope that we could show you that there is no one-fits-all solution, but that many pieces have to come together to make fossil-free aviation 2045 come true. We, from our side at the Swedish Energy Agency and from the companies, will continue our journey towards reaching the goal. And would you like to join us? You're more than welcome. Please reach out to us and send an email to our speakers or to my colleagues at the Energy Agency. We are looking forward to hearing from you, and we wish you a very good day now. And don't forget to log in 15 minutes again for the main stage program at Sweden Innovation Days. Thank you very much.